Well, hello. Today we're going to look at section 6.1, which introduces the idea of transformations, which means changes. And there are quite a few definitions you're going to need to write down that are going to show up in this section. And actually, this section will take quite a bit of work on your part. So let's get right to it. One type of transformation is called a translation, which just basically moves a figure from one point to another point, and often it's up, down, left, right, etc. And so this current question is talking about taking this box and specifically point D and moving it from where it is and moving it to the new point, which is at 15 and 4. So I'm going to go ahead and do that. I'm going to first find, well, where's 15? Oh, it's over here. And 4, 1, 2, 3, 4 up. You can see where my dot is there. That would be the new point D, and so you often indicate that with a line on the top, which is called prime. And so if all the other points line up the same, we would just count blocks over. So in the original diagram, from D to C is 4. So if I count 4 to the left and put a dot there, there's my new C point. And then the other points are 6 up from there. And so this is a translation, and it went, looks like if I look at point D, it went up 2, and then over 3, 6, 9. So up 2 and over 9 would be the way that you could describe that translation. You're also going to need to do this activity on page 219, and it requires you to do some translating on your own, so you can make note for yourself on page 219. And this activity needs to be done, and it has to be included in your portfolio for this unit. Just another example of a question. This is talking about a logo for Capilano, which is a management program, outdoor recreation management program in BC. And they want to take that logo and print it off so that you can put it onto a vehicle window. The problem is when you go to print something and put it onto a sticker, it would be backwards. So they have to create kind of the reflected image of this. And in order for you to do that in this situation, you would actually have to reflect it over the y-axis to create a new picture on the opposite side with the letters being backwards. So really what you're going to end up doing is, if you look at the letters, you're going to reflect it so that you can write the word backwards. And obviously you do it more carefully than I'm doing it now. But everything has to be backwards so that when it prints off, you get it right side up. So every point would be reflected kind of where it is over top of the y-axis. And so that's just an example of a reflection being useful. We do that in our own house when we're, you can buy this paper that you can print off and put it onto t-shirts with an iron. You have to make sure that you always do that backwards. You're also going to have to deal with some rotations. Rotation meaning moving around. And this question is asking you to take this picture, which is of a geometric shape. I don't know how you would describe that geometric shape. But to rotate it around to make a snowflake. So currently we have a picture on the top there, and I am going to take that same image and just rotate it around, and this would be 90 degrees, this would be 180, and I think if I go ahead and set the transparency here, we'll be able to maybe see the other picture. Oh man, that's going to take forever. Forget about that. Anyways, you're supposed to rotate it a bunch of times, and by doing that, you would create the image of a snowflake when you reflect it at 90 and then 180 and then 270, and you'll get some practice on your assignment. You'll also have to deal with scaling things smaller and larger, and if you look back at your definitions here, that is a dilation. Okay, a tessellation is what we just did, which is taking the same picture and repeating it to make some sort of a eye-appealing design. Here we're going to decrease or increase something, and in this question we have a scale factor. A scale factor is 2/3, meaning that it's going to be smaller by a factor of 2/3, and this candle, which is called a mid-size candle, is 9 centimeters wide. That sounds pretty huge to me, and 18 centimeters tall, and we're supposed to find a dilation of it by a scale factor of 2/3. So we times each of these by 2/3, And when you do that, you get new dimensions, which would obviously be smaller. 2/3 of 9 is 6 centimeters, and 2/3 of 18, I believe, would be 12 centimeters. And so that's an example of a dilation. And you can also figure out a scale factor, and we have here first information at 12 centimeters wide, 8 deep, and 10 tall. And the second one is larger, and the question is, what is the scale factor? Is there a scale factor, in fact, for you to get that answer? And so really what that question is saying is there a number that we can multiply 12 by and get 15? And is that the same number we would multiply 8 by to get 10? And is that the same number that we multiply 10 by to make it into 12? So right away, the first thing that I notice is that this will be 1.2. And here, I don't think that will be 1.2. So is this a dilation? No, because this scale factor isn't constant. In order for it to be a dilation, the scale factor would have to be constant. So there are quite a few definitions, as I said, to write down. You need to practice your skills and build your skills, and then get the check done. Don't forget to get a math on the job done for this unit. Roots of math, maybe you want to change things up and do that first instead of leaving that till later in the unit. It's up to you. Please make sure you ask me when you have difficulties, and we will work together to get this finished.